Hi, this is Mrs. Basin, and today we're going to talk about the periodic table. So we know that the periodic table is a chart that shows us all of the known elements. Currently, there are 118 elements that are listed on the periodic table. Most of them can be found in nature, but then a lot of them have been created in labs. The elements are arranged in order of their increasing atomic number. So we've talked about how the atomic number identifies the element, tells us how many protons that particular element has. So that top number in the box on the periodic table is the atomic number. That's how it's arranged. Dmitry Mendeleev is a Russian scientist that is credited with the origin of the periodic table, but there were lots of other scientists whose work went into the periodic table that we know and that we use today. He came up with one of the first ones. He left spots where he didn't have elements that would fit in those particular places. And according to historical records, when those elements were discovered, they fit right into those spots that he had left open for them. The names of those elements come from many different sources. So some of the names have to do with Greek, Latin, or German words that describe the properties. Some of them are named for locations, especially a lot of the synthetic elements are the ones that were created in labs. A lot of times they're named in honor of scientists. They're named for locations on where they were created. And then some of them are also named after Greek and Roman gods. So there's a lot of different sources for those element names. The element symbols are either 1 or 2 letter abbreviations for those. The first letter is always capitalized, but the reason that a lot of them they're not just the first letter or couple letters of the name that we would know is because sometimes those symbols are actually based on the Greek, Latin, or German words or other words from other languages. The arrangement of the periodic table is going to be important because the placement of an element on a periodic table helps us know what the properties are, even if we don't know anything about that specific element. So the metals are all to the left of the stair-step line, and the stair-step line you'll be able to see in the classroom. Our classroom periodic table has a piece of tape that kind of divides it up. On this diagram here, the blue elements kind of represent where that stair-step line is. So the ones to the left, with the exception of hydrogen, are the metals. The nonmetals are to the right, so the yellow ones, and we have to include hydrogen in that, and we'll talk later about why hydrogen is actually on the wrong side. And then the metalloids border the stair-step line. So the metalloids kind of represent where that stair-step line is. So if you're to the left of the metalloids, it's a metal, to the right, it's a nonmetal, and in the middle, what divides those are the metalloids. From the lab, you know that metals have some shared properties. So metals are good conductors of heat and electricity. We describe metals as malleable. That means you can hammer them into a sheet and change their form without them breaking apart. Metals are considered ductile. Those are able to be drawn into a wire. So if you think about something like copper, you've probably seen copper wire before. And they're lustrous or they're shiny. Nonmetals also have general properties. So nonmetals are poor conductors of heat and electricity. And if they're solid form, so nonmetals can be solid, liquid, or gaseous form. If the nonmetals are solid, then they tend to be brittle. So if you think about the sulfur or the carbon that you observed in lab, that's a good example of brittle solids that are nonmetals. The metalloids are interesting because they have properties of both metals and nonmetals. One use or property that metalloids have is they're semiconductors. So that means they have an intermediate electrical conductivity that you can change and control. So they have a lot of use in electronic devices. The metalloids, like we said, border the stair step, and we'll talk about how you can remember what those are just by looking at the classroom periodic table or looking at a periodic table. But the metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. So those are the metalloids, and we'll have to make sure that we know those and can identify those. Finally, the periodic table is divided into groups or families and periods. Groups are the vertical columns, so the groups go down on the periodic table, and on most periodic tables they're numbered from 1 to 18. Periods go across, and those are numbered from 1 to 7. If elements are in the same group, they have similar properties. So in class, we're going to go through and do a little research on what the different properties are of the different groups. And again, this is helpful to know because even if you don't know properties of a specific element, if you can find its location on the periodic table and you know the general properties of the group, then that will help you identify properties of that particular element.